Writing good requirements and transmitting them efficiently to the rest of the team remains a challenge for systems engineers. The Syndeia NX interface offers an alternative to document-based requirements. With Syndeia, requirements in SysML can be provided as a native NX CAD file, identifying reference planes, bounding boxes, keep-out zones, and other geometric features the CAD designer must respect in designing a component or assembly. In this video, we will demonstrate how to construct such a requirement by geometry and transform it into an NX part. Let's consider a set of requirements captured in MagicDraw, as shown in this requirements diagram. On the left, we have a specification with 3 requirements governing the payload. The bounding box is a cylindrical volume 600 millimeters in diameter and 2,000 millimeters long. The resulting center of gravity, when payload components are installed, must rest within 50 millimeters of a position inside the volume. Keep-out zones between adjacent pieces of payload equipment must be at least 100 millimeters wide. To the right, we have a block structure which refines these requirements as geometric solids. It consists of a top-level block with the stereotype NX part that represents the overall specification, a cylinder block used as a part property named volume, a sphere block used as a part property named COG, or center of gravity, 2 more cylinder blocks used as part properties named keep-out 1 and keep-out 2. These last 4 blocks have the added stereotype NX part feature. We have used the refine relationship to show how each NX part feature depends on a text requirement, though this is optional. Cylinder and sphere are 2 of 7 geometric primitives that Syndeia recognizes and can transform to the corresponding NX shape. The full set is included in this diagram, which is found in the part package in the model, and could be included as a library in any model you build. Each shape has a specific set of value properties, which Syndeia recognizes and transforms to the right shape parameter in NX. In this diagram, the notes explain the role of each value property. If you want to use these part features for a SysML to NX model transform, you cannot change either the block names or the value property names within them, nor can you add new shapes or values. If you do, Syndeia will not be able to handle the model transform. You can, however, change the default values of the value properties to change the size, origin, or orientation of the feature. Returning to our payload requirements, the bounding box cylinder has an origin at 0, 0, 0, a vector orientation along the z-axis, a diameter of 600, and a height or length of 2,000. Syndeia recognizes 2 units for such dimensions, millimeters or inches. This is set as a tag value for the NX part payload requirement and carries over to each of its features. If we open the specification window for the payload requirement block, go to Tags, and scroll down, we see under the NX part heading units which we can add, in this case as millimeters. And these will be transmitted with the dimensions to NX later. The center of gravity is a sphere of 100 millimeters diameter, offset from the origin of the bounding box by 1,500 millimeters along the positive z-axis. This is the locus in which the final center of gravity must lie. There are 2 cylindrical keep-out zones 100 millimeters wide and strung out along the z-axis, dividing the bounding box into 3 separate areas for payload components. The number and position of these keep-out zones represents a specific configuration of the payload, not just the generic requirement captured in the text. We need to have 3 blocks named cylinder, 1 for the bounding box and 2 for keep-out zones. But the default values of the dimensions and origin are different for each. In the browser, we see that the large cylinder is directly under the UAV payload requirements package, but the other two are each in their own package. Since each package is its own namespace, we have defined 3 separate blocks named cylinder with different default values that can play different roles in the payload geometric structure. The actual model transform is simple. We launch the Syndeia dashboard, go to the Connection Manager, open a window to our local file system, and find the empty folder that I have created to receive the new CAD model. With the connection type set to Model Transform, we drag the top-level block, Payload Requirement, onto the empty folder. Confirm that we want an NX CAD model. In a few seconds, the transform is complete. We can open the CAD file right from the dashboard, or even from the Magic Draw diagram. Which launches NX and opens the model. Here we can play with the display, rotating it, panning it, and highlighting the different features. The center of gravity, keep out 1, keep out 2, and the overall volume. The CAD designer now has an unambiguous model of the requirements to begin the design from, a design which may be brought back to the SysML model as we showed in the 13.1 demonstration video. Syndeia does not provide compare and sync capabilities for this transform. If we go to the Syndeia dashboard and look at the connection summary table, we see that there is only a single connection between the top-level block and the CAD part. Let Intercax know if you foresee new use cases in your work that require extensions to current capabilities.